So we're going to start in on chapter 2 today. We're going to start chapter 2. Chapter 2, we're going to talk about, so 2.1, inductive reasoning and conjectures. Okay, this is on page 74 of your book. Okay, so it's called inductive reasoning and conjecture. Okay, so there is a thing called inductive reasoning. Okay, inductive reasoning, if you go in the little bottom part of your book, it says, when several examples form a pattern and you assume the pattern will continue, this is what we call inductive reasoning. So inductive reasoning is that we observe patterns. We observe patterns and make conclusions. Okay? We're going to make conclusions, and what do we call those conclusions is a statement you believe to be true based on inductive reasoning would be called a conjecture. Okay? A conjecture is a statement based on inductive reasoning. Does anybody know what the opposite of inductive reasoning is? Can anybody tell me what that is? Does anybody know what the opposite of inductive reasoning is? It is what Sherlock Holmes is famous for. You know what kind of method?
The detective?
Huh?
Like, not detective.
He's a
but
detective, yes, but there's a certain method that he uses.
Like observation?
Well, yeah, he draws conclusions, right? It's called deductive reasoning versus inductive reasoning, okay, where he applies logic to solve a problem, okay? All right. And that'll come up later on, so we'll get to that. So in inductive reasoning, you're observing a pattern, okay? So let's look at example 1 and see if we can go and make sense here. So example 1, find the next item in each pattern. Monday, Wednesday, Friday. So what would be the pattern? According to the pattern, what would be the next one?
Saturday?
It's every other day, isn't it?
Sunday.
Yeah, Monday, Wednesday, Friday, and then Sunday, correct? So it'd be Sunday. Next one is 3, 6, 9, 12, 15. What's the next one based on the pattern?
18.
18, we're adding 3, right? We're adding 3 to the previous number to get the next number, right? And in C, I have error that goes like this, and then like this, and then like this. So the next one would look like that, I would assume, right? Because it's going around like this, yes, right? Okay, so that was example 1. So that's exactly what we're talking about. We're talking about observing a pattern and making a statement. And that statement is called what was it called? Holden.
Conjunction or conjecture.
Conjecture, right? It's called a conjecture, okay? So the reason I'm kind of going over this pretty hard is because these are new words that you're probably using, right? So example number 2, complete each conjecture. Complete each conjecture. Number 2, A. the product of an even number and an odd number is what? Okay. So, and then it shows us examples or a pattern. So it says 2 times 3 is 6. 2 times 5 is 10. 4 times 3 is 12. 4 times 5 is 20. So what can we say about the product? The product is an even or odd number? It's an even number, right? Based on the pattern? Okay, so that'd be A. B. Number of segments, we're on page 75. The number of segments formed by n collinear points is, so if I have 2 collinear points, I have how many segments? I have 1 segment. If I have 3 collinear points, how many segments do I have? I have 1, 2, and then I have the big one, 3, right? So I have 3 of them. Okay. If I have 4 collinear points, it goes like this. I'm gonna have 1, 2, 3, 4, 5, 6. Actually, I have 6 of them. Okay. So there's definitely a pattern forming here, right? There's a pattern. You can see the pattern, right? Okay, so here, this we have now 5. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 of them. Okay. So the conjecture is, if we have n collinear points, I would have the sum of 1 through n number of line segments. Okay, so that would be the conjecture, right? Because if I have 1, 2, 3, 4, 5, I have 1, 2, 3, 4. So if like I would have to add 1, 2, 3, 4 to get 10. So if I have n number of collinear points, number of line segments that I can make is actually, it's going to be n minus 1. So the sum of 1 through n minus 1, because n here is 5. Over here, n is equal to 5, n is equal to 4, n is equal to 3, and n is equal to 2. Okay, so when n is equal to 2, I add to 1. When n is equal to 3, I add 1 and 2. When n is equal to 4, I add 1, 2, 3. N is equal to 5, I add 1, 2, 3, 4. Okay? Okay, so that was kind of interesting. That was kind of fun. Example number 3. To learn about the migration behavior of California gray whales, biologists observed they counted the number of whales seen along each route. Make a conjecture based on the data. So if we look at the data, what kind of pattern do I see there? What's the pattern there? There's not an exact pattern a pattern in the exact numbers, but what is always happening? What is always true? Which has more whales? It's the shore route, right? The shore route always has more whales that have been observed, right? So the conjecture that we can make is that most of the whales travel along the shore route. Okay, again, we're observing a pattern. We're looking at a pattern and making a statement. Okay. Okay, let's flip the page. Okay, so wait a minute, before we flip the page, on the bottom, there's what is called a counterexample. Okay. So you can make a conjecture, which means a statement based upon your observations, but all it takes is one counterexample to say that what you say is wrong. If you can find a counterexample or an example that does not fit that pattern that you said and therefore does not fit the statement, then you're going to be able to say that that statement or conjecture is not correct. Okay? So let's go to page 4. Let's go to, I'm sorry, page 76, example number 4. And let's see if we can do some counterexamples here. Okay, A for all positive numbers n, so A for all positive numbers n, show this conjecture is that this is true. Okay, so let's give this a shot. So if I have 10, does this work? That looks to be true. Right? What if I had 4? That's true. What if I had 1? Is that true?
Yes.
It is true, right? Because this is 1. And I'm going to get 1 is greater than equal to 1 is greater than equal to 1. It's true, right? Because there's an equal sign there on the bottom, correct? So it looks to be pretty true until I say that n is 1/2 or 0.5. Is that true? What is 1 over 0.5? This is 2, right? So this is now becomes not true, right? Because you're saying that 0.5 is greater than equal to 2, right? Okay. In other words, when n is greater than 0 but less than 1, this does not work. Okay, so that would be a counterexample. So 0.5, n equals 0.5 would be a counterexample to this conjecture, making the conjecture incorrect or untrue. B. For any 3 points in a plane, there are 3 different lines that contain 2 of the points. So if I have 3 points, I'm going to have 3 different lines, 1, 2, 3, that contain 2 of the points. There's 1 line, 2 line, and 3 lines. So this is true all the time unless I have points that are lined up this way. In other words, if I have 3 collinear points, the statement or conjecture does not work, right? So this would be a counterexample to that conjecture. Okay. In C, the temperature in Abilene, Texas never exceeds 100 degrees Fahrenheit during the spring months, which is March, April, and May. Is that always true? In May or March, it was 97, April was 99, May was 107. So that is not true, right? Because in May, we showed that it was 107, which is definitely higher than 100 degrees. Okay, so that would be a counter example to the conjecture that in the spring months in Abilene, Texas, the temperature never exceeds 100 degrees Fahrenheit. Okay? And we are done with 2.1. Are there any questions there? So the big things to get out of this lecture is inductive reasoning. Inductive reasoning is based upon observing a pattern. Okay, if you're going to make a statement based upon observing a pattern, that's called inductive reasoning. And a conjecture is the statement that you make based upon the inductive reasoning or the observing of the patterns. Okay? So let's go ahead and stop.